Today we have Rohin Shah. Rohin is a graduate student here at UC Berkeley's Center for Human Compatible AI, or CHAI. He's co-authored quite a few different papers, and he is soon to be a research scientist at DeepMind. Um, Today we'll be talking about his paper on the feasibility of learning rather than assuming human biases for reward inference. This appeared at ICML 2019, and the co-authors were Noah Gundotra, Peter Beal, and Anka Dragan. Welcome to the show.
Yeah, thanks for having me, Daniel. I'm excited to be here.
All right. So I guess my first question is, what's the point of this paper? Why did you write it?
Yeah, so I think this was the first piece of research that I did um, after joining Chai. And
Hmm.
at the time, I wouldn't necessarily, I just wouldn't agree with this now. But at the time, the motivation was, well, when we have a super intelligent AI system, it's going to look like an expected utility maximizer. So that determines everything about it except, what utility function it's maximizing. It seems like the thing we want to do is give it the right utility function.
Okay.
A natural way to do this is inverse reinforcement learning, where you learn the utility function by looking at what humans do. Um, but a big challenge with that is all the existing techniques assume that humans were optimal, which is clearly false. Humans are systematically biased in many ways. Um,
Hmm.
it also seems kind of rough to specify all of the human biases. So this paper was saying, well, what if we try to learn the biases? Just throw deep learning at the problem. Does that work? Is this a reasonable thing to do? So that's why I initially started looking into this problem.
Okay. So basically, like the story is, yeah, we're going to we need to learn um a utility function from humans, and we're going to learn it by seeing what humans do and then trying to do what they're trying to do, and in order to figure out what they're trying to do, we need to figure out how they're trying to do it. Is that a
Exactly.
fair summary? Okay.
Yeah.
And specifically, you're talking about learning rather than assuming human biases. Could you say more about exactly what type of thing you mean by bias?
Yeah, so this is bias in the sense of cognitive biases. Like if people have read Thinking Fast and Slow by Tversky and Kahneman, it's that sort of thing. So a canonical example might be hyperbolic time discounting, where we basically discount the value of things in the future more than could be plausibly said to be rational. In the sense that maybe right now I would say that I would prefer two chocolates in 31 days to one chocolate in 30 days. But then if I then wait 30 days and it's now the day where I could get one chocolate, then I'd say, oh, maybe I want a chocolate right now rather than having to wait a full day for two chocolates the next day. Um,
Okay.
so that's an example of a kind of bias that we study in this paper.
All right. And I guess to give our listeners a sense of what's going on, could you try to summarize the paper, maybe in a minute or two?
Sure. Um, so the key idea of how you might try to deal with these human biases without assuming that you know what they are is to assume that the human has not just a reward function, which we're trying to infer, but also a planning module, let's say. And this planning
And you put
module,
that in scare quotes, right?
yes, scare quotes, exactly.
Okay.
Planning module, scare quotes. And what this planning module does is um, it takes as input the environment, the world model, um, where the human is acting, as well as what reward function the human wants to optimize, and spits out a policy for the human. So this is how do you decide what you're going to do in order to achieve your goals? And it's this planner, this planning module that contains the human biases. Um,
Okay.
like maybe when if you think about overconfidence, maybe for maybe this planning module is uh, tends to select policies that choose actions that are not actually that likely to work, but the planning module thinks that it's likely to work. So that's sort of the key formalism. And then we try to learn this planning module um, uh, using a neural net alongside the reward function by just looking at human behavior, or well, simulated human behavior, and inferring both the planner and uh, both the planning module and the reward function that would lead to that behavior. Uh, there is also a bunch of details on why that's hard to do, but maybe I will pause there.
Sure. Well, I guess that brings up one of my questions. Isn't that literally impossible, right? Like, how can you distinguish between somebody who's like acting perfectly, like optimally, with one set of preferences or one reward function? You might say in the reinforcement learning paradigm. Isn't that just indistinguishable from somebody who's being perfectly suboptimal, doing like exactly the worst thing with exactly the opposite reward function?
Yep, that's right. And indeed, this is a problem if you don't have any additional assumptions, and you just sort of take the like most naive approach to this, where you just say do back propagation end to end learning to just maximize agreement with human behavior. You basically just get nonsense. Like you get a planning module and a reward that together produce the right behavior. But if you then try to interpret the reward as a reward function and optimize for it, that's just like is basically pretty arbitrary, and you get like randomish behavior. Um, and like in our experiments, we show that like you get if you do just that, you get basically zero reward on average. If you optimize the learned reward, these are with reward functions that are pretty symmetric, so you should expect that on average you'd get zero if you optimize the random reward.
Okay, cool. Yeah. So and so you're using some kind of extra information, right?
That's right. So there are two versions of this that we consider. One is like unrealistic in practice, but like serves as a good intuition, which is suppose there's just like a class of environments, and the reward functions for and behavior for like let's say half of them, some fraction of them, and then for the other half you only see the behavior and not the reward functions. And the idea is that if the planning module is the same across all of these, you can learn what the planning module is from the first set where you know what the reward function is, and then like use that planning module when talking about the second set where you're inferring the rewards. So in some sense, it's like a two-phase process where you first infer what the biases are, and then you use those biases to infer what the rewards are.
Okay.
There's a second version where instead of assuming that we have access to some reward functions, we assume that the human is close to optimal, meaning their planning module is close to the planning module that would make optimal decisions. And what this basically means is we initialize the planning module to be optimal. And then we essentially say, okay, now reproduce human behavior, and you're allowed to like make some changes to the planning module such that you can better fit the human behavior, which you could think of as like introducing the systematic biases. But since you started out near the started out as being optimal, you're probably not going to go all the way to being like suboptimal or anything like that.
Okay. So yeah, I guess let's talk about those. In the paper, you sort of have these assumptions 1, 2A, and 2B,
Mm-hmm.
right? Which you talked about a little bit, but I was wondering if you could like more clearly say like what those assumptions are, and also how like in the paper you give sort of natural language explanations of what these assumptions are. But I was wondering if you could say like, okay, how that translated into code.
Yeah. Um, so the first assumption one, which was needed across both of these two situations I talk about, is that the planning module is the same in scare quotes again for similar enough environments. So in my description, I assume that you've got access to this like set of environments in which the planning module works the same way across all of those environments.
Yeah, what does that
Now,
mean?
yeah, it's not totally clear what that means. Like, I wouldn't be able to write down a formal meaning of this, because if you try to say, because there's always the planning module that says, well, if the environment is, this specific environment where the ball is on top of the face or whatever, then, output this policy. But if it's this other environment, then do this other thing. And that's technically a single planning module
Yep.
that like works on all of the environments. And so in some sense, it's just like, is there a reasonable or there's a reasonable or a simple planning module that's being used across all of the environments. And I think this is like this sort of like dependence on reasonableness or simplicity is just something that we are going to have to depend on, not necessarily in this particular way, but like if you don't allow for it, um, you get into problems well before that. For example, like the problem of induction in philosophy, which is just like, how do you know that the past is a good predictor of the future? How do you know? How can you know that, like, how can you eliminate the hypothesis that, like, tomorrow, the evil god that has so far been um, completely invisible to us decides to, like, turn off the sun? Like,
Okay.
yeah. Sorry, maybe I.
But what does that amount to? Like, does that just mean you use like one neural network in like
That's right.
different
In our code,
environments?
we just use a single neural network. Neural networks tend to be biased towards simplicity. So effectively, it turns into that becomes like a simplicity, kind of like a simplicity prior over
Okay.
the planning module.
All right. I guess I sort of understand that. So that was assumption one. How about 2A and 2B?
Yeah. So assumption 2A is the version where we say that the demonstrator is close to optimal, and we don't assume that we have any rewards. In that one, what we do is we take our neural net that corresponds to this planning module and we train it to produce the same things that value iteration would produce. And value iteration is an algorithm that produces optimal policies for the small environments that we consider. And so by training, basically, we're just training our neural net to make optimal predictions.
Okay. And you're initializing at this optimal network.
Right. This training happens in a like initialization phase.
Okay.
Like I would call this training the initialization for the like subsequent phase when we then use it with actual human behavior. Like this all happens before we ever look at any human behavior. We just like simulate some environments. We compute optimal policies for those environments with value iteration, and then we like train our planning module neural net to like mimic those simulated optimal policies. So this all happens before we ever look at any human data.
Okay. And so assumption 2A essentially comes down to like when we train our networks to mimic humans, we're going to be initialized at this demonstrator that was trained on optimality.
Correct.
Um so one question I have is like why initialization seems like kind of a strange way to use this assumption. Like if I were being like my default is to maybe be kind of Bayesian and say like, okay, we're going to have some sort of prior, um, or like maybe we're going to do this like regularization thing where I know what the weights are of an optimal planner and I'm going to L2 regularize away from those weights. But
Yeah.
initialization, the strength of that like quote unquote prior or something that you're putting on the model is going to depend a lot on like how long you're training, what your step size is, and such. So
Yeah.
yeah, why did you choose to use initialization
I
instead of
think
anything else?
really that was just the first approach that occurred to me. And so I tried it and it seemed to work
All right.
reasonably well. I think so. I think I don't think I had ever considered regularization. That seems like another reasonable thing to do and does seem like it would be easier to control what happens with that prior. So that does seem like a better approach, actually. I think I would lean away from the Bayesian perspective just because then you have to design a hypothesis space, and so on. And the whole point
I
of this
mean,
is to, sorry.
oh, I mean, regularization is secretly Bayesian anyway, right? So
Oh,
it's
sure.
fine.
Yeah, fair enough. I mean, I would say like I wouldn't be surprised if this initialization was also secretly Bayesian, given the like other hyperparameters used in the training.
Okay. All right. So that was 2A. Then there was also assumption 2B, right?
Yeah. So assumption 2B is pretty straightforward. It just says that we have this set of tasks over which we're assuming the planning module is the same. Um, and for half of those tasks, we assume that we know what the reward function is. And the way that we use this is that we basically both the planning module and the reward function in our architecture is trained by end-to-end by gradient descent. So once when we have assumption 2B, when we have the reward functions, we set the reward functions and the human behavior, and we freeze those. And we use gradient descent to just train the planning module. And this lets the planning module learn what the biases are in planning. And then once we have the after we've done this training, the planning module is then frozen, and it now has already encoded all the biases. And then we use gradient descent to learn the reward functions on the like new tasks for which we don't already have the rewards. And so there you're just inferring the reward functions with given your already learned model of what the biases are.
Okay. Um, yeah, I guess one comment I have on that assumption is initially it seems realistic. Like sometimes people are in situations and you know what they want.
Mm-hmm.
And then you think about it a bit more and it seems unrealistic because like you're assuming you know exactly what they want. But I think it's a little bit less unrealistic than the second phase thinks. For instance, one cool research design you can do in microeconomic studies is to have lottery tickets that you use to pay people with, right?
Mm-hmm.
And like the nice feature about lottery tickets is like if you assume that people want the lottery tickets more than they want nothing. A nice feature of lottery tickets is that if you get two lottery tickets, that's like exactly twice as good as having one lottery ticket.
I
Because
guess
by
that,
the linearity of
yeah.
probabilities and
Okay.
expected utilities, you know?
Yeah.
So there are some situations in which you can actually make that work.
Huh.
I just wanted to share that research design. I think it's quite neat.
Wow. I love that this is a way to just like get around the fact that utility is not linear in money.
Right?
That's
Yeah,
cool.
it's excellent. Unfortunately, you only have so many lottery tickets you can give out, right? So you can't do it indefinitely. Like at some point, they just have all of the lottery tickets and they won the lottery and you can't give them any
Yes,
more. But
that is
until
true.
then, yeah. All right. So I want to jump around in the paper a little bit.
Mm-hmm.
So the question I have is in the introduction, you spent quite a bit of time saying like all the like strange ways in which humans can be biased and like suboptimal or something.
Mm-hmm.
Reading this, I almost think that this might be a good argument for modeling humans maximally entropically using something like the Boltzmann distribution, because there you're just saying, look, I don't know what's going on. I'm gonna have no assumptions, um, but then I'm just gonna use that probabilistic model that uses the least assumptions, and in practice it does all right. So I guess I'm wondering, what do you think of this as an argument for Boltzmann rational models?
Yeah, I mean, so I think I want to note that the like actual maximally entropic model is like one that just uniformly at a random chooses an action.
Which is in the Boltzmann family.
True, but if you did that, you'd never be able to learn about the reward because
Yeah.
the human policy just by assumption does not have anything to do with the reward. But so you need like sort of I actually mostly agree with this now. I am not entirely sure what I would have said, 2.5 years ago when I was working on this, but I mostly agree with this perspective where like what you need out of your model is it needs to like assign a decent amount of probability to all the actions, and it also needs to rank like actions that do better as having higher probability, and like that's it. Those are the important parts of your model. And if you take those two constraints, it's like the Boltzmann model is a pretty reasonable model to come out with. And I think like you would expect, I think, but I'm not sure, that this, well, it should have, at the very least, hurt your sample complexity in terms of like how long it takes you to converge to the right reward function compared to if you knew what the biases were. It also probably makes you converge to the wrong thing when people have systematic biases, because you sort of attribute, like when they make systematic mistakes, you attribute it to them, like in some sense the generative model that Boltzmann rationality is suggesting is that like when humans make systematic mistakes, the Boltzmann rational model is like, well, I guess they like every single time they're in this situation when they flip their coin to decide what action to take, the coin comes up tails and they take the bad action. It's just like a weird generative model. Um,
Hmm. I
like
mean, the actual model would be that the human prefers that action in that situation, right? Or that would be the actual inference that a Boltzmann
correct.
model.
Yeah, so either it would make the wrong inference, or it would have, if it somehow got to the. I think more I'm saying is like if we assume it's, you might expect that the Boltzmann rational model would not get to the true reward, because if it were at the true reward, it would be having this like weird generative model, and so yeah, so it would like make the opposite inference where it would be like anything that humans systematically make a mistake on, it would expect that humans wanted to do that for like some reason at least. We would have to invent some explanation via which humans want that action was a good one.
That's an interesting thread. I might talk about. Let me get a little bit more into the nuts and bolts of the paper before I pick up on that thread more.
Sure.
Another question I have is when you're doing these experiments, when you're learning models of the human demonstrator, use value iteration networks or VINs, right?
Hmm.
Could for our audience, could you say what is a VIN?
Yeah. So a value iteration network is a particular architecture for neural networks that is able to that mimics the structure of the value iteration algorithm, which is an algorithm that can be used in AI to learn optimal policies for tabular Markov decision processes. Um, Point is, it's an example of a neural net whose architecture is good for learning a learning algorithm, which is the sort of thing that you want if you want to have a planning module.
Okay, and it works in grid worlds, right?
Yes, I believe people have used it elsewhere too. Like, I want to say someone adapted it to be used on graphs, but I used it on grid worlds, and the basic design is definitely meant for grid worlds.
Sure.
It like basically stacks a bunch of convolutional layers and then uses like max pooling layers to mimic the maximization in the value iteration algorithm.
Sure. So I guess one question that I have is like, it seems my vague memory of iteration networks is that they can express like the literally optimal value iteration, right?
That's correct.
Um, so if that's true, why bother learning, doing gradient descent on optimal behavior to get a model of an optimal agent rather than just like setting the weights to be the optimal thing?
Um, there was a reason for this. I'm struggling a bit to remember it. I'm guessing. I mean, partly it's that actually setting the weights takes some amount of time and effort. It's not a trivial trivial. There's not a trivial way to do it. It depends a bit on your transition function, depends a bit on your reward function. Like it only becomes it's able to express literal optimal value iteration when the horizon is long enough, which I think it was not in my case.
Okay.
And also, I believe you might need multiple convolutional layers in order to represent the transition function and the reward function. But I am not sure. It's possible that those two things happen because of the horizon issue.
Okay.
Yeah, I did at one point actually just like sit down and figure out what the weights were to encode optimal value iteration because I was very confused why my value iteration network was not learning very well. And then I like found out that I can't do it with my current architecture, but if I like add an additional convolutional layer to the like part that represents the reward, then I can. So I added that, and then even the learned version started working much better. It was great.
Okay. I mean, if you knew that adding this could let you express optimality, why not? I don't know. I guess I have a
So
vendetta against people learning things.
there is a reason that
Against people training models that learn things. I'm in favor of human learning.
yeah.
Let me clarify. Um,
So there was a
but you were
reason.
saying,
The version that I wrote computed the optimal policy,
hmm,
but did not compute like the optimal explanation for human behavior under like. So A, it wasn't Boltzmann rational,
okay,
and B, it's like computation of the Q values is like kind of sketchy. I don't remember if it was I don't think it was actually the right Q values. And I don't remember why. It might just be that it like didn't work for Boltzmann rationality, but you'd get the case where it'd be like if up was the correct action, you get like up having a value of like 3.3, and then like left having a value of like 3.25, and so on. And so like you'd get the right optimal policy, which was the main thing I was checking, but like you wouldn't actually do very well according to the loss function it was using.
okay. So I guess the other half of this question is, what biases? Like you had this list of biases at the start. Um, are value iteration networks able to express these biases, and in general, what kinds of biases are they able to display?
That's a good question. Um, I mean, in some sense, the answer is anything. Like they can express arbitrarily, like their neural nets.
I mean,
Uh,
your value iteration networks, they had a finite width and a finite depth, right?
um, yeah, my value iteration networks, hard to say. Um, I think they could definitely express the underconfidence and overconfidence ones. Well, sorry, maybe no, even that you have to like compute the amount by which you should be underconfident or overconfident. I'm not sure like there were enough layers to do that exactly. I think in general the answer is the networks I was using could not, in fact, literally exactly compute the biases that I was doing, but they would get very very close. In the same way that like neural nets usually cannot just like depending on your architecture they can't exactly multiply two input numbers, but like they can get arbitrarily close.
Okay. Um, so I guess my this leads to another question of I guess the setup for your paper. You sort of encode biases as having this like as having your planner be the slightly wrong value iteration network. Um, at least what at the time of doing inference. But interestingly, you assume that the world model is accurate. Now, when I think of bias, like either like cognitive bias or the kind of thing that I might read in Thinking Fast and Slow, a lot of it is about like making wrong inferences or having a bad idea of what's going on in the world. So I was wondering why you chose to have bias specifically in the planning phase and focus on learning that.
Yeah. um I think like I think two answers. The first answer is, this was the one that I had some idea of how to deal with.
All right,
But
that's
like
fair.
second answer, um you can view like the ones where you're like you have a bad model of the world. You can also view that as your planning module like transforms the true model into a bad model and then does planning with that bad model. This is actually what value iteration networks kind of do. Like they learn the
Ooh,
transition function. The weights of the value iteration network encode what the transition function is.
huh. I mean,
Or
I
sorry,
guess
that's a way
if
to
I were
interpret
really,
it. Yeah,
yeah, if I were interested in understanding humans, I don't know. It seems to me that typical human bias is not well modeled by like somewhere in your brain has like the exact model of how everything in the world works, right?
that seems right. Yeah, I mean, in
I
this
mean, point
case,
taken about you've got to focus on something though.
yeah, I think in this case, it was actually that the transition dynamics were the same across all the environments, and the value iteration network was allowed to learn a warped version of them.
Okay.
Which is not the same thing as like when humans look at the world, they like misunderstand what the transitions are. This is more like when we came up with our model of what the uh, human planner was doing, we put into it this like incorrect model of how the world works. So that is still a difference, but it isn't like we learned a planner that gets the correct transition dynamics and then warps them. Um, like that I know I said that earlier. That I more meant that like the optimization was doing that, or possibly I just said a wrong thing earlier. I'm not entirely sure which I did.
Okay. Um. Cool. So I guess next, our listeners are probably wondering, um, what happened. Like, I gather you did some experiments and got some results. Could you describe, like, briefly, roughly, what experiments you ran and overall what were the results?
Yeah, so it was pretty simple. We just simulated a bunch of biases in grid worlds, and we let's see. I'll just look at the paper. It was a naive and sophisticated version of hyperbolic time discounting, a version where the human was like overconfident about probability about their actions, the likelihood of their actions succeeding. Another one where they were underconfident about the likelihood of their actions succeeding, and one where the human was myopic, so wasn't planning far out into the future. So we had all of these biases. Um, we would then generate a bunch of environments and simulate the human behavior on those environments. So this created a data set of like um, environments in which we had human behavior, and we also had the ground truth rewards that were used to like create that behavior. So we had a metric to compare against. Then we would take this data set, and then depending on whether we were using assumption 2A or 2B, we'd either remove all of the reward functions or only half of the reward functions, and give it to the algorithm. And it had to predict what the reward functions were. It had to predict the reward functions that we didn't give it. And then it was evaluated on how well it could predict those reward functions. In particular, it was if we then optimize the inferred reward functions, how much of the true reward function would that policy obtain?
Okay, so importantly, you're measuring the learned planner learned reward pair rather than just the learned reward function.
No, sorry. We take the learned reward function and we optimize it with the perfect planner, not the learned
Oh,
planner.
okay. All right. So you're evaluating the word function by if you planned perfectly with it, how much reward you would get, which is a pretty stringent standard, right? Because if your reward
Yeah.
function, well, actually in a tabular setting, if your reward function is a little bit off, then the optimal policy only gets a little bit less reward. But in general, like this can be a little bit tricky.
Yeah, it's a stringent setting in the sense that like in at least in the environments we were I mean, it's kind of stringent and kind of not stringent. Like in the environments we were looking at, it mostly mattered whether you got the highest reward grid world entry correct, because that was the main thing that determined the optimal policy. It was not the only thing. It was the main thing. So you needed to get that correct mostly. But it also mattered to know where the other rewards were, so that because like if you can easily pick up a reward on the way to the like best one, that's often a good thing to do. Sometimes, uh, I forget if this was actually true in the final experiments that we ran, but sometimes if the reward is far enough away, you just want to stay at like a maybe slightly smaller but closer reward and just take that instead. But yeah, for the most part, you mostly need to predict where is the highest reward in this grid world.
Okay. And what kind of results did you get?
Yeah. So if you don't make any assumptions at all, well, if you take assumption one but not assumption two A or two B, the ones that let you get around the impossibility results. So you just don't run the initialization where you like make the uh, neural net approximately optimal. Then you just get like basically zero reward on average. So that was the first result. Was like, yep, the impossibility result. It really does affect things. You do have to make some assumptions um, to deal with it. Uh, then for the versions that actually did use assumptions, we found that it helped relative to assuming either a Boltzmann rational model of the human or a perfectly optimal model of the human.
Okay.
But it only helped like a little bit. And this was only if you like controlled for using a differentiable planner. Sorry, but from using this like planning module, because like it introduces a bunch of approximation error. So when I say we compared to having a Boltzmann rational human model, I don't mean that we like used an actual Boltzmann rational model. I mean we simulated a bunch of data from Boltzmann rational model, trained the planning module off of that data, um, and then used that trained planning module to infer rewards. And this was basically to say, well, differentiable planning modules are like not very good. We want it to be consistent across all of our comparisons, but that's obviously going to like not hobble the like. Well, it's not going to hobble it relative to the others, but if you were just going to assume a Boltzmann rational model, you wouldn't need to do this differentiable planner thing, and so you would do better.
Okay. So basically you said like assuming either 2A or 2B did really help you a little bit compared to assuming neither but using a differentiable planner, but using a differentiable planner is like quite a bit of loss.
That's right. Um,
Okay. And do you have info about like how 2A and 2B compared if you like only wanted to use one of them?
yeah, so you should expect that 2A does quite a bit. I mean, I expected that 2A would do. Sorry, I forget which is which. I expected that 2B would do quite a bit better than 2A. So like, if
For
you knew
for our
what,
listeners who might have forgotten what 2A and 2B are.
yeah, I was about to say, if you knew, like, I thought that it would help significantly in the to like know what the reward functions were. So like you know half the reward functions, and that lets you ground your learning of the biases.
And you
Um,
thought that would help more than like training your learned model starting from optimality.
yeah, because like in some sense, you there's like there's now some sort of ground truth about the biases. There's like a good learning signal. There's like no impossibility result that you're trying to navigate around. It seems like a much better situation, and it did do a bit better, but only a little bit better. I was like surprised at how
Only a
small
little
the
bit
difference
better than
was.
what?
If you had assumption 2A instead, where you just initialize to optimality.
Okay, so it was slightly better to know the rewards compared to assuming that it was close to optimal, but not actually very much better, is what you're saying.
Yep, that's right. Um,
Okay,
yeah, and like really, it was like a lot better in two of the conditions that we checked in, a little bit worse in a couple of the conditions we checked in, and on average, it washed out to be a bit like a little bit better.
okay, all right, that's interesting. So one thing I that's interesting to me about your results section. If I read section 5.2, it comes off as more scientific than most machine learning papers, I want to say. Like, it just in the sense that it seems to be interested in carefully testing hypotheses. And in the paper, you have these headings of manipulated variables and, you know, um, dependent measures and various comparisons. So I guess I'm wondering, like, firstly, why did you adopt this slightly non-standard approach? And maybe related to this, what do you think of the scientific rigor of mainstream machine learning?
Oh man, controversial questions.
Let's start with the
I
easy one.
Yeah.
Why do you adopt that approach?
I mean, the like actually correct answer is I am advised by Anka, and this
Who's
is how
Anka?
Anka Drogan is a professor at UC Berkeley. She is one of my advisors, and the of my advisors, she had the most input into this paper, and she is very big on doing you know more like scientific um, experiments more in the style of like normal scientific experiments as opposed to the typical ML experiments. So the first answer is because my advisor is Anka. Um, but I do agree with Anka about this, where like there's just like if there definitely is a point to the normal ML way of of doing experiments where where this is an oversimplification, but like the point is basically to show that you do better than whatever previously happened. Like it does the this structure does lead to significant progress on any metric that is deemed to be something that you can do this sort of experiment on. And so it like does tend to incentivize a lot of progress on in cases where we can like crystallize a nice metric. I am less keen on uh, these sorts of experiments though because I don't see the main problems in AI research can as we have these metrics and we need to get like higher numbers on them. I think that there are like much more all of the things in AI that are interesting to me, even if we set aside AI safety, it particularly look more like, oh my god, what's going on with deep learning? It's got all these like crazy empirical facts like that I wouldn't have predicted a priori. What's going on there? Can we try to understand it? Um, or like those are the vein of the types of questions that I'm interested in, and for those sorts of questions, it's if you are running an experiment, like you would run experiments to like learn new information. If you already know how the experiment's going to come out, it's kind of a pointless experiment to run. Like the point of running that experiment is to successfully publish a paper, and I've done my share of that, but those aren't the experiments that I'm usually excited about.
All right. Um, so I guess now that we're getting more philosophical, um, my understanding is that you think of yourself as an AI alignment researcher, an AI safety researcher, or something. Is that right?
Yes.
Okay. So how do you, and if you do, how do you see this paper as fitting into some path to create safer aligned AGI?
Yeah. So I think there's like the path that I mentioned way back when at the beginning of this podcast. Um,
So that was the idea that we were going to learn some like utility function, and just like whenever we had a task we wanted an AI to do, we would like have a human do that task, and then have the or what does that even look like? Yeah. Could you say more?
yeah, I mean, I'm not particularly optimistic about this path myself, but it's not a an obvious or like I feel like while relying just on learning a reward function from human behavior, that can then be just perfectly optimized. I think I'm fairly confident that that will not work. But it seems likely that there are plans that involve learning what humans want and having better methods to do that seems valuable. Whether it had to specifically be about systematic biases and whether they can be learned, I think that part I feel is like less important at this point. Um, but you do need to account for human biases at some point. Um, so to outline maybe more of a full plan or something, you could imagine that we build AI systems and we're training them to be essentially helpful, to be like good personal assistants with superhuman capabilities at various things, but still, in thinking the way personal assistants might do, in the sense that like they're not sure what your preferences are, what you want to happen, and so they like need to clarify that with you, and so on. Like this feels like one of the like subtasks that such an agent would have to do.
Like inferring what you want.
Yes, exactly.
I guess if I think about machines that I employ to do things for me, um, like if I want video conferencing software, or even if I want if I were to get an employee, not that I've done that. Usually, the way I get good video conferencing software is that I do not first demonstrate the task of relaying video from and audio from one place to another very quickly. Right? That's like because I just can't do that. I can't even do an approximation of that. And similarly, like with employees, like I guess there's probably a little bit of instruction by demonstration, but I don't think that like that's the main way we communicate tasks to people, right? Am I wrong about this?
No, that seems right. I think you're conflating the like evaluation that we did with the technique. Like the technique is trying to infer what the reward is, right? So like this is I think the a better analogy would be like I don't know. Since it's like sort of assuming optimal demonstrations, it's more like assuming that you have like a magic camera that like gets to watch the person as they go about their day-to-day life, and they're like I guess also they're not aware about this camera, which is not a great assumption, but let's assume that for now. So like you just sort of watch the human go around with their life, and you're like, okay, based on the fact that they, you know, um, had cake today, I can infer that they would like cake or something. But maybe then you're like, oh no, but actually humans have this like short-term bias. So I shouldn't infer that they don't care about their lifespan or their overall level of health. It could just be that even though reflectively they would endorse being healthy, having a long lifespan, they in this sort of in the moment went with a short term preference for like nice sweet cake.
I
Um,
guess. Okay, I want to. This always comes up in these discussions, and I want to defend eating cake. I feel like you can care about your lifespan and also eat some cake.
Wait, that's totally true. I'm just saying you don't want to over update on it.
You don't want to, sure, but I mean, we already know that. I don't know. In like, like presumably your AI spy camera is also going to see you put on a seatbelt, right?
Mm-hmm.
Like, I feel like there's. I don't know. I feel like there's already a bunch of information about you caring about your life, and like eating a bit of cake is not like strong evidence that you don't actually care at all about your future lifespan. Even under naive, even if you assume that people were acting optimally. That's my I don't know. I just feel like all of these examples are super biased against cake. Like
Fair
like
enough.
oh, we wouldn't want people to think that eating cake is ever a good idea according to human value. Sometimes cake's
uh, you,
nice.
you know, okay, sure. I'll stay away from the cake, but I think I
All right.
wouldn't say that like if you assume perfect optimality in that situation, I think like you don't learn something like oh humans care about having a long lifespan. You learn something more like humans don't want to be in violent accidents, but they don't mind like dying of whatever it is that cake causes. Um, right? Like you can always inject more and more state variables to distinguish behaviors in order to explain why humans seem to like not care about their life in one case, but do care about their life in the other case.
Okay.
And like that's also a thing you don't want your systems to do.
So I guess going up a level is the idea that I'm going to like that the way AGI is going to work is like the product that AGI Corp, the corporation that sells AGI, this product is going to be okay. You're going to have this like I don't know. You'll wear like a GoPro on your head for a while or something, um, and the system is going to just like learn roughly what you value in life, and it's just going to like generically do things to get you more value to make your life more like you want it to be. Is that it?
Um, Plausibly,
Because
that
that
seems.
seems a little bit scary. I don't know.
I don't know.
I,
That
I
seems
think I think I
plausible to
want a
me
product to do a
eventually.
thing, right?
Sorry, say that again.
I guess it seems to me that like if I want a super intelligent system, I'd rather first like I'd rather have a super intelligent system that did a well-defined task rather than generically making my life better. Or at least I think a like when I think about AI alignment, it seems like we would be able to figure out the how to create an aligned safe AI that does one task before we figured out how to create an aligned AI that generically makes all of your life better. And I I'm kind of on board with the arguments that we don't know how to have an aligned AI that like does one concrete task, even if like you know that you can still allow problems of vagueness of specifying like what the task is if the task's like build a like thriving city or something.
Hmm.
But I find it weird that like so much of the field is about like generically make your life good.
I
You know?
feel like there's not that much of a difference between these. Like, build a city, build a like good city seems like pretty similar to build an agent that generically helps me. And it turns out that like current in this particular case, what I really want to do is make a city. Like you still want like you would still want these personal assistants to like defer to you, and like if you give like explicit instructions to obey those, and that like I think you do want to shoot for that. So it doesn't feel like those are that different in terms of the actual things that they would do. In terms of like research strategies for how to accomplish this, I guess the versions where we're trying to build AGIs that can do these like broad, vague tasks, well, we're like saying, okay, we need to first figure out how to make an AGI that like does this task. It seems to me, I just don't see what benefits this gives, how this makes the problem easier than just like build an AGI that's trying to help me.
So I mean, one benefit is well, it just seems like okay. Let's go with the city task first, right? The thing with the city task is um you're not like I think the way to do it is not like okay, I'm gonna watch a human try to do urban planning for a month or something, and then like the AI am going to take over. Like that's not what you're suggesting, right? Is
I'm
it
not.
actually? I can't tell.
No, I think so. For the city planning case in particular, this algorithm is going to be like. I mean, it might infer like some sort of like common sense details, but it's not going to infer what a good city looks like because you just don't get information about that by looking at a single human. So you need something else. So I think I'm more like, let's leave this paper aside. I am not at all convinced that it will matter at all for like AGI alignment. I would not bet on that.
All right.
But I do think the like general idea of like, oh, the AI system is going to try to help us and will be like inferring our preferences as part of that. That is something I'm more willing to stand behind. I think in this case it looks more like the AI system when you tell it, hey, please design me this city, it like goes around and like reads a bunch of books about how to design cities if such books exist. I don't know. It like looks at what previous urban planners have done. It like maybe surveys the people who are going to live in the city to figure out what they would like in a city. It like periodically checks in with you and says like, this is what I'm planning to do with the city. Um, does that seem like good to you? Um, And if I then say like, this is the reason that's bad, this doesn't seem good to me for X reason, it can say like, well, I chose that for Y reason because I thought you would prefer Z, but if you don't, then I can switch it to this other thing.
Okay.
I'm maybe
So
rambling a bit here.
yeah, so I guess you're imagining, okay, we're gonna have like these AI systems, they're gonna do tasks that are like kind of vague, but the way they're gonna do that is they're gonna infer human preferences, like basically in order to infer what we mean when we say please build a good city.
Hmm.
And they're going to do that by like um a whole bunch of sources of information, and maybe like 1/5 of what they're doing is like looking at people who are trying to do the task and trying to infer like what the task was, assuming like they were, you know,
Oh,
doing a good job at trying to do the task.
I don't know about 1/5.
Well, you said a lot of things, and very few of them sounded like inverse reinforcement learning to me.
Yeah, sorry, I was imagining much less than 1/5, to be clear.
Okay, all right, a small amount. I'm happy with
Yeah,
less than or equal to 1/5.
sure.
Okay, yeah, and I guess this gets a bit into other work of yours that you've collaborated on that we won't be talking about right
Hmm.
now. But I guess I can kind of understand this. But to answer a question you asked me a little bit earlier, I think like the reason that I want to do the like plan a city rather than generically make my life better. Firstly, I think I want to be clear that like if indeed we are trying to create an AGI that like can plan a city rather than generically make your life better, um if somebody says that out loud, then we can check if our research helps with that. Um so that's one reason to be a little bit clear about it. The reason to prefer planning a city to generically make your life better is, firstly, intuitively it seems like an easier job. Like if you're planning a city, the way you're generically making my life better is by planning a city that's good. If you're generically making my life better, you're generically making my life better in every single way, including presumably the way of like maybe occasionally planning a city to make my life better. So it must be strictly easier to do the first thing. And then thirdly, I prefer the plan a city type task because at the end you can check if a city got planned and like roughly evaluate the city and see if it's a good city. And like that seems like a target that you're going to know if you hit it more easily than you're going to know if this AI system generically made your life better. I'm wondering what you think of those points.
Yeah. I think I didn't understand the first point, but maybe I'll talk about the second and third first, and then we can come back to the first point.
I'll say the first point. Maybe it wasn't responding to anything, but I think that like the first point is just we should try to be clear what problem our research is trying to solve. And I think that uh, and yeah, I guess the second and third point are arguments that like planning a city and generically make your life better are like importantly different problems, and
Hmm.
about why one of them is better than the other.
Yeah, I mean, first point seems good. Being clear about what we're trying to do seems good. Uh,
But it's so
I
rare in papers, right?
it is. It's annoyingly difficult to get papers that say exactly what we're trying to do to be published. It's
Mm.
very sad. Um, I tried with Nirep, so we'll see whether or not it works. Um,
Okay.
but for the second point, I agree that in if you I agree that the like planning a city type task must be should be strictly easier if you're imagining that your help me generically AI system could also be asked to like plan a city. I think that's like more of a statement about capabilities though, where I'm like, okay, but like I sort of see the like safety, the alignment, the like benefit, the like good properties that we're aiming for here in the AI safety and AI alignment coming from the like trying to help you part. And like we can have different levels of competence at helping. So like maybe like initially we just have agents that are trying to help us schedule meetings on a calendar and, not doing anything beyond that because they're like not competent at it. And, as we get to more general agents, we'll like need to ensure that these agents know what they can and cannot do, so that they don't try to help us by doing something that they are incompetent at, where they just like ruin things without realizing it. And that's like one additional challenge you have here. But I sort of see this as like most of the safety comes from the agent being in this like being helpful in the first place, and that's the reason I'm aiming for that instead of the like things like plan a city. Um,
Sure.
the Remind me what the third point was.
Um. Oh, the third point was that you can check if you've succeeded at planning a city more easily than you can check if you've generically like had your whole life been a bit better.
Yeah, I guess I'm like I don't see why that's true. Like, it seems like I totally could evaluate whether my life is better as a result of having this AI system. Like maybe the AI system like tricks me into thinking my life is better when it's not actually, but like the same thing can happen
Hmm.
with the city.
Um, I mean, to me, it seems like building a city is a better defined task. Like, hmm, I guess there are so many ways. Like, there are just yeah, maybe this is wrong. It just feels like there are so many more ways in which my life could like plausibly be better. But at least with the city, I don't know. It feels like I can check if it's there or not.
Yeah, I mean, I think so. Like, it depends a little bit on how you're going to quantify the helpful part. Like, maybe you're just like you know, as like one metric. Like, did the AI system follow the instructions that I gave? Was it competent at those instructions? Did it like infer something that I wanted without me having to say it, or something like that? But I feel like we can, or I would guess that at least like all the people who hire personal assistants are in fact able to tell whether those personal assistants help them or not, and like hopefully they can distinguish between like bad and good personal assistants. Seems
I
like
mean, I
that
think
should be
that's because
doable.
they give the personal assistants specific tasks, like please do my taxes or
Yeah, I
please
mean
answer
we
these emails.
plausibly will do that too. But like I mean they're like even our personal assistants can do like often I expect take a lot of initiative. I guess one example from for me personally is like, um, I read the alignment newsletter, and I guess not that recently anymore, for quite a while now, it's been published by somebody else, um,
Hmm.
and specifically Georg from the Future of Humanity Institute, and also Sawyer from Barry helps run it as well. And like at some point, I was like, you know, we should probably switch from this like plain like pretty plain template, that Mailchimp has to something that has a nicer design. Um, and I like mostly just said this, and then like Sawyer and Georg just sort of did it, periodically sending a message being like, "This is the plan," and I'd be like, "Yep, thumbs up." And then like at the end of it, there was a design. It was great, and like I like in some sense I did specify a task, which is like let's have a pretty design, but it really felt like it was like a fairly vague kind of sorta instruction, but not really. That they just then took and executed well on. And I like sort of expect it to be similar for AI systems.
I think that's fair. Yeah, I guess the other thing I wanted to pick up on was, um, in your answer, it sounds like you think there's this core of like being helpful. That like there's some like technique to be helpful, and you can just like be better or worse at it. And once you know how to be helpful, you can be helpful at like essentially anything. Um,
Hmm.
that's my interpretation of what you said. I'm wondering like to what extent you think this is right, and that like you see the important part of the AI alignment or safety community as like trying to figure out computationally what it means to be helpful.
That seems broadly correct to me. I think I wouldn't say that it's um, the entire AI alignment community's thing that they're doing. Like, I think there's a subset that cares about this and that different subset does other things
Oh,
and
my
has.
question was whether you think that's what they should be doing,
Uh,
or whether that's what the problem is.
I think there's like some meta level outside view that's like, oh man, we should be encouraging diversity of thought or whatever. But if you were like, what is your personal thing that like seems most promising to you, such that you'd want to see at least the most resources devoted to it? Yeah, I think it's right to say that that would be like, yeah, that is like trying to help you, or trying to do what you want is how I think Paul Christiano would phrase it. Um,
Okay.
and
Yeah. It sure seems like there are a lot of sub problems of that. Like, if I imagined that being my main thing, it's like, how much have I made my life easier?
I like
But,
it does feel like this is like a domain independent core. It's got like a domain independent core or something. Like if you look at um, assistance games, which were previously called cooperative inverse reinforcement learning games, or maybe just cooperative inverse reinforcement learning. Um, like I feel like that is a nice crisp formalization of what it means to be helpful. It's still making some simplifying assumptions that are like not actually true, but like it really does seem to incentivize quite a lot of things that I would characterize as like helpfulness skills or something. Like it incentivizes preference learning, it incentivizes, asking questions when being unsure, like it like will have you like and it incentivizes like not um asking questions only when they become relevant and not like asking about every possible situation that could ever come up at the beginning of time.
hmm.
Um, it incentivizes like learning from human behavior, like passively observing and learning from human behavior, which is the sort of thing we were talking about before. So I don't know. It feels like this is a thing that we can, in fact, get agents to do in a relatively domain independent way. And if we succeeded at it, then there would not be existential risk anymore.
Okay. Well, on that note, I think we've had a good conversation. Hopefully, our listeners understand the paper a little bit better, but of course, I would recommend reading it. The name of the paper is On the Feasibility of Learning Rather Than Assuming Human Biases for Reward Inference. Today's guest has been Rohin Shah. Rohin, if viewers wanted to follow your work, what should they do?
Yeah, I mean the most obvious thing to do is to sign up for the alignment newsletter. This is a newsletter I write every week that just summarizes recent work in AI alignment, including my own. So that's a good place to start. It's also available in podcast form. Um, Other things, I like write a bunch of, well, I write some stuff on the alignment forum. So you could go to alignmentforum.org and look for my username, just search for Rohin Shah. Um, and I think the last thing would be, the papers that I've written, which are all available, or links to them are all available on my website, which is rohinshah.com. You can also find a link to sign up to the alignment newsletter there.
All right. Thanks for today's interview, Rohin.
Yeah, thanks for having me.